Okay, physics fans, welcome back. This is Physics 11, Projectiles. This is from the Projectile package, page 13, number 26. One of the last ones. And a unique one, it's good. A boulder rolls off a 47-meter high cliff, launching at 19 degrees below the horizontal at a speed of 15 meters per second. How far from the cliff's base does the boulder land? And how much time does it take before it hits the ground once it's launched? So I've drawn and went ahead a little bit here, and there's the boulder rolling down, and it takes off. It goes into a projectile motion at this point, and it's being launched at 15 meters per second in that direction from a 47-meter high cliff. They want to know, where does it land and how much time does it take? So it looks like we don't have too much information. We have a bit here, so let's just take a look. First of all, before you start filling in the table, we got to get the horizontal and vertical components of that velocity. So let's bring back some numbers here that I erased. There we go. It's being launched at 19 degrees below the horizontal, so we draw our triangle as I've drawn here. 15 meters per second is the hypotenuse. It's down at 19 degrees below the horizontal. So we have a horizontal component and a vertical component. But the vertical component is down. That's unique. This is what's new about this one. Usually projectiles launched up. This is kind of launched in a downward direction. So we do the cosine, because that's the adjacent cosine. So ka toa, ka, C-A-H, ka, that's the adjacent. So that's why it'll be the cosine here. And if we always draw this angle with respect to the horizontal, then the horizontal will always be the adjacent. And that means you can always trust to put cosine 15 here. And that's just for someone who's been asking. There we go. You can trust 15 cosine 19 degrees will always be the horizontal. And consequently, across the way, we have this opposite. And so we have to use the sine. Because we have the hypotenuse, we have the opposite. So S-O-H, opposite. So that'll always be the sine. So we get 15 sine 19. We just quickly plug them into the calculator. And no, that's been cleared. So we just quickly go. Okay, so the sine 19 degrees times the hypotenuse will be the length of that side. And so as we go 15 sine 19, and since we're going to do the cosine before I even copy it down, I might as well do that. 15 cosine 19, because it'll be on the display here. And we put those numbers onto the page here. There they are, magically put on there. 14.8. So pause it if I'm going too fast, go back and take a look at it. That explains why the hypotenuse and cosine are just like that. And the hypotenuse and the sine are like that. So we can fill in the table. 9.8 is down. The 4.8835 is down. The 47 is down. So this is unique. This is the first projectile that I've done in the package here where they're all aligned already. That's pretty good. And the horizontal is 14.1827. So if we're going to solve it vertically first, we'll put the numbers in. And we get VI, which is 4.8835 plus 2 times A times D. A and D are the same direction. Since they are the same direction, if you put them both as negatives, this term will be positive. And if you put them both as positives, this term will be positive. So no matter if down is negative or down is positive, this term is always positive. And this is always squared, so this term is always positive, no matter if that's up or down. So that's positive, and this time this is positive. If they're opposite, if this is going up, then this will be a negative term. So when we solve that, we get VF squared, it'll be down. We take the downward answer of that because it's down is the answer. Then we want to find the change in velocity, VF minus VI. And this time, since they're both in the same direction, we're going to actually be subtracting them this time instead of adding, because it would be opposite directions. So 25 is the change in velocity. Why do we need that? Well, we do that to get the time, because from the acceleration formula, acceleration is the change in velocity over time. Time is the change in velocity over acceleration. Put those two numbers in, you get the time in seconds. And then, once we have the time, then we can get the range, which is the horizontal distance, which is A. So in fact, we answered B first, then A. We had to do it that way. So we got the velocity and the time. We multiplied them together, and we got the horizontal range. So that's answers everything. I'm going to just fill in the table now. So we have in blue 25.858 down, and the time is 2.6386. 63, whoops. And the range is 37.422. There we go. It didn't ask for final velocity. It didn't ask for the total displacement. It didn't ask for any of those things, which we could do. We could continue on, but didn't ask, so we won't cover it. We won't make this question harder, because that's all covered in question 27. Thank you very much. Subscribe, click the like button, comment lots. Thank you.